Hello and welcome to another video in the Houdini tutorial series. My name is Charles Mara. In this video, we're going to be looking at particle effects in Houdini FX. To accomplish this, we use the popnet. Now there are two types of popnet, the popnet and the pop network old. We're going to be exploring the differences between these and how they relate to simulations. Without further ado, let's get into it. Now, when we first begin in Houdini FX, we notice one of the first things on our shelves tools is particles. These particles are often pre-made and therefore are sometimes hard to control. We're going to start by making our particle effects at a very basic level and work our way up. The first thing we need when creating a particle effect is a node to contain all our particles. For this, we simply click the Tab key on the menu and type in a geometry node. You'll notice that the geometry node creates a file, and by double-clicking inside, we'll just delete the file. Next, we'll create our pop network. We're going to be going with the old instead of the newer pop network. We'll start to explore the newer pop network towards the end of this tutorial, but for now we're going to stick with the old. One of the first things you'll notice is that you get a small error. By holding the middle mouse button on any node, you can see some of the parameters, and at the bottom you see a warning. For now we're going to ignore this warning, as it'll quickly fix itself. If we double click inside our pop network, you'll notice that we're in another level. To simply create a particle effect, we click Tab, and we can click Source. Now, this source needs geometry, so we're going to use our first context geometry. Right now we don't have any geometry in our geometry node, so we're going to remedy that by clicking the Tab key again, and let's search for a grid and place that down anywhere. Each of these is our context geometry, so we're going to go ahead and insert our grid into our first context geometry. We're going to go to a rain effect. We're going to go for a rain effect. So first, we're going to switch our viewport by holding the space key and the left click button. I then move pan upward by clicking the space key again and holding the middle mouse button. We're going to have the center of our grid be a little higher since we're going for a rain effect. So we're going to adjust the y-axis by 5. Next, we're going to go inside the pop network. You'll first notice that there are actually a couple particles being created. We're going to switch our emission type from points to surfaces random, since we don't want our points to be in an order. Next, we're going to go to our birth tab, and we're going to switch our constant activation rate to 0 and our constant birth rate to 0. There are two types of ways to create particles, either through the impulse or the constant. Either one of these is fine, but you should never have both on at the same time unless you know what you're doing. We're going to increase our impulse birth rate to 10. And we're going to play our particle simulation. And you'll notice that it begins to create particles randomly on the surfaces. I'm going to go back to the geometry level and increase the amount of rows and columns. This will allow our particles to be placed more evenly. Next, we want our particles to flow downward, like rain. There's many tools up here that we can use, but by clicking the tab menu, we can look at our behaviors, or even our forces, to look at other tools. For now, we're going to use a force tool. As the node suggests, it forces our particles to do certain things. I'm going to go ahead and force it at a -7, as well as increase the amount of noise we get. This will make our particles a little more random. If I click the play button, you'll now notice that my particles are falling. I'm going to adjust the camera and look downward now. At 300 frames, at 30 frames a second, this is a 10-second animation. And you'll notice the particles are falling, but they're not really stopping anywhere. If this animation were to continue, the particles would grow indefinitely, and the program would eventually crash because there's too many particles. To remedy this, we want our particles to stop. So how do we do that? We're first going to create another grid. We can name our grids source, and we'll name this one catch. We're going to insert this grid into our second context geometry and double click into our pop network. You'll notice that we have a collision, and this is the node that we want. We're going to attach our nodes and display our latest node. For the source geometry, we're going to use our second context geometry. And because our force does have a bit of noise, we're going to go ahead and make our catching grid a little larger than our source grid. If we play our simulation, you'll notice that the particles disappear when hitting the second grid, our catching grid. Under behavior, we can see that the particles are actually dying on collision. Now, rain doesn't normally die when it collides, it instead bounces. So we're going to switch our behavior to bounce on collision. We'll notice now that it bounces pretty high back to the top of our grid. We can adjust these settings by adjusting the tangent down a bit and the normals down a bit. By hovering over any of these, we can get a description of how the effect works. By lowering the tangent and the normals, we're getting the energy loss from the tangent on collisions, which basically means the particles are losing energy as they bounce. We're next going to switch our final behavior to die on collision, since we don't want our particles to last forever. You'll notice that our particles now bounce a bit, and now they're dying, like normal rain would. As we continue, we can now add some more force, but let's try it with a wind. Wind is another force that we can use. And let's say I want to have it on a -5 on the z-axis. As we play our simulation, we'll now notice that the particles are going over. We can remedy this by having our grid on the bottom be bigger. We can adjust the wind any way we want, including adding some noise. Lastly, we're going to want to add some color to our rain. We can do this by adding a color node. If you notice, our keyframes are already animated. So if we try to change anything, it's going to change right back. To change the color, we simply need to delete the channels and change our blue up to 1. We're going to turn off this pink button, which is our show button. This will turn off our grid so that we just see our particles. And now we can see how they're behaving. Lastly, we want our particles to have some type of geometry to them. Right now they are just points. To do this, I'm going to add a copy node and plug our pop network into the second copy. And I'm going to go ahead and add a sphere. I'm going to make this sphere pretty small at a 0.03, 0.03, and a 0.05 to have the particles have a little more of a shape to them. If I go to the copy node and go up to the object level, we'll now see that our spheres are mapped onto our particles. I can now name this rain and play it forth. And we'll notice that our spheres are now mapped onto our particles or copied onto the particles. Now, we'll notice that our particles are going rather slow. When we turn on our real-time playing, you notice that they're now going really slow because they're now playing at real time, how we would normally view this. A quick fix to this is to go back into our pop network and add more force. Let's try a -75. You'll now notice that while our force is good, our wind has now disappeared. To remedy this, we simply go and crank up the wind. And by doing this, I now no longer have to make the catching grid any larger. And we still get the wind on the z-axis. We can adjust this further by adding more force, more wind, more collision, as we choose to see fit. One of the things you'll also notice is that I can't play the simulation backwards. That means if I saw an error somewhere in here, I'd have to play it forth. This is a bit more remedied in the new pop network, which we will look at a later time. If we simply create it and go into it, we can see that it is very similar. But now we have this pop solver, which does a lot of the work for us. At this point, we see some similar nodes, our source and our pop object. This is a lot closer to a simulation, which we will eventually get to. But for now, our rain is good as it is. This will conclude our tutorial in Houdini FX concerning particles. Our next tutorial, we will look at the new pop network and how we can adjust and deal with some of the issues that that particle system brings. Thank you for listening. My name is Charles Mara, and this is another video in the Houdini tutorial series. Thank you.